Our next presentation is from James. He's going to speak on geometry, West, East, and Vedic. He's a founder and chair of IAVM. James has researched and taught VM for over 40 years and has led international teacher training programs, public courses, and lectures on the subject. He has written numerous books and has published numerous papers and articles promoting Vedic system. He has a long experience of curriculum design for math in school. James.
Thank you, Ramya. Share screen. Can you see the
Yes, yes, we can see.
Yes,
we can see.
yes.
Thank you so much, James. Go ahead.
Right, this is about, well, really, it's an investigation into certainty of knowledge as seen through approaches to pure geometry. And in this presentation, I'll be briefly covering pure geometry in ancient Greece, geometry in ancient India, Islamic geometry, and then the application of Vedic math sutras in geometry. The reason I'm looking at this is the approaches are different, as you will shortly see. We'll start with ancient Greece. Often referred to as Euclidean geometry, pure geometry deals with spatial mathematical relationships and figures. In contradistinction is analytic geometry, invented by René Descartes, which uses coordinate axes to represent algebraic expressions and equations. Geometry in ancient Greece evolved over many centuries, in fact, more than 1,000 years, possibly influenced by mathematics from Egypt. It reached its high point around 500 to 400 BC. This is evidenced by the incredibly refined geometry used in the Parthenon, which includes many harmonious proportions, together with aspects of spherical perspective and projective geometry. The most famous extant writings are the 13 books of Euclid, round about 300 BC, called the Elements. Similar to Parnini's grammar, the Ashtadhyayi, Euclid systematizes geometry, most likely by collecting together previously known results and then formalizing them. He does this by laying down a small number of axioms, postulates, and definitions, and then proceeds to establish geometric certainties based on these principles. I'll run briefly through what these the basic elements are. He starts with axioms, and the 5 axioms state general self-evident truths, such as if equals be added to equals, the totals are equal. And then the 5 postulates are statements required for the particular field of study. For example, to draw a straight line from one point to another. Definitions are statements to clarify the terms used. For example, a line is breadthless length. Propositions, Euclid's elements logically set out propositions, each of which is proved from previously established propositions and principles. This approach became a strong element in development of so-called Western thought processes. Educational value. Greek geometry solves problems through deductive proof. This is the main reason why remnants of pure geometry are still taught in schools and colleges around the world, some 2,500 years after they were formulated. This approach provides an unparalleled mental training in logical reasoning, helped by the fact that diagrams and figures can easily be visualized. In this system, deductive proof is used to establish certainty of knowledge. Now, in ancient India, the approach is very different from that set out by Euclid. Surviving texts from ancient India, such as the Sulba Sutras, do not set out principles and propositions needing to be proved. Instead, they tend to set out the result and then use it for practical purposes relating to architecture, surveying, constructing altars, and astronomy. As an example, there is a story of Bhaskaracharya's proof of Pythagoras' theorem, where he walked into a room, drew this diagram, and set out one word, behold. In ancient India, the criteria for validity are very different from those of ancient Greece. They also have a wider scope. The Sanskrit word for certainty of knowledge is pramana, and ancient texts identify 6 types. These are pratyaksha, perception by the senses, anumana, inference, deduction, upamana, analogy or comparison, shabda, verbal authority, revelation, anupalabdhi, non-perception or negative proof, and artapatti, postulation from circumstances. Now, I'm not going to go into great detail on these, but I'll give an illustration. Do you remember learning what a circle is? I'll let you think about that for a minute. How did it happen? Typically, at some early age, perhaps 3 or 4 years, someone points out a shape and says, that's a circle. Perhaps the shape is the circular top of a jar or pot. We learn the name in whatever language we speak, but then there's a sort of magic that takes place. The shape that's pointed out is circular, but the direct perception is of an ellipse. And yet, springing forth from we know not where is the knowledge of pure circle. Direct perceptions of actual circles are very rare, yet we somehow connect with absolute certainty of the shape. The process involves a combination of pramanas, pratyaksha, perception, shabda, verbal authority, and artapatti, postulation from circumstances. It alludes to Plato's description in Republic Book 6 and also the Meno of unmanifest knowledge being brought forth through the right circumstances. In other words, the knowledge is already present, it just needs to be drawn out of the subconscious into the conscious. Exactly the same is described in Vedantic philosophy, where the knowledge is stored in avyakta prakriti, unmanifest nature, and then brought forth into conscious understanding and material reality. Arriving at certain knowledge of such a shape as a circle is very simple. Now compare this simplicity with Euclid's formal definition. He first defines the following: line as breadthless length, straight line as a line which lies evenly with the points on itself, boundary as the extremity of anything, figure as that which is contained by any boundary. And then he comes out with this sentence. This is translated directly from the Greek. A circle is a plane figure contained by one line, such that all the straight lines falling upon it from one point among those lying within the figure are equal to one another. And that point is called the center of the circle. It's quite complicated. But he's talking about the idea of radii of equal lengths being drawn from a point in the middle. Both approaches are very different, but both have their uses according to necessity. In teaching children, certainty of simple geometric properties can be established through visualization and appropriate questions. Another example for comparison of approach can be seen in one-circle theorem as follows. The theorem states that when a diameter forms the base of a triangle and the third vertex lies on the circumference, the angle formed is a right angle, and this is one of the circle theorems. Euclid's proof in Book 3, proposition number 31, depends on 11 previous proofs listed here. However, simple observation and acknowledgement of symmetries of circles and rectangles can give certainty almost immediately. I'll talk a little bit, just a touch on geometry in Islam. There is a long tradition of decorating mosques with very beautiful geometric patterns. Images of God are not possible and have therefore become prohibited. Quran 6, no vision can grasp him, but his grasp is over all vision, for he is the most subtle, omniscient. The beauty and complexity of Islamic geometric patterns is deeply connected to spirituality and symbolism. The patterns reflect the underlying order and harmony of the universe. Starting with the circle, which represents pure unity, the designs use harmonious symmetries in polygons to create these intricate patterns. Here are some examples. Now, a little later, I will show you a short video of constructing one of these Islamic patterns, because it relates to both the Islamic style and also the Vedic sutras, as I'll mention in a minute. Several of the Vedic math sutras have repeated applications in geometry. These are as follows, but I'm not going to go into the details so much, but just to list them at the moment. Ekadikena Purvena, by one more than the one before. Paravarcha Yojayet, transpose and apply. Vilokanam, by mere observation. Lopanasthapanabhyam, by elimination and retention. Anurupyena, proportionately. Vyashti Samashti, individual and universal. Purana bhyam, by completion and non-completion, and shunyam samya samuchaye, when the totals are the same, there is no difference. And I'm going to show a proof of the intersecting chord theorem and briefly look at how the Vedic math sutras apply. So here we've got a circle with two chords, PR and QS, and they intersect at T. T is not in the center of the circle. And it turns out that the lengths are connected as follows: A times B equals D times C. Euclid's proof of this theorem is very complicated, but I'm going to show a simple proof using Vedic sutras. Just give you an example. If QT is 3 units long and TS is 8 units long and RT is 4 units long, then it will follow that TP is 6 units long, because 3 times 8 is equal to 6 times 4. the proof goes like this. We first join P to S and Q to R. And then because of angles in the same segment, we have these two green angles and the two red angles are equal. And this is expressed in the sutra Shunyam, Samya Samuchchaye, which is to do with equality. We then take these two triangles and turn them around and flip one over by transpose and adjust. So we have triangle TSP and triangle TRQ. And now you can see the angles are in the same orientation. And so the angles being the same, we have similar triangles. One is a proportion of the other, anurupyena. The next step is to expand both the triangles. The triangle on the left, TSP, is expanded by a factor of D, and the triangle on the right is expanded by a factor of A. And the result is that the left-hand triangle has these two sides, CD, C times D and A times D. And the triangle on the right has those two sides as A times B and A times D. And you can see that T dash P dash is equal in length to T dash Q dash. And so the triangles are now congruent. And hence, A times B is equal to C times D. Okay. Now I'm going to just show this short video. I just need to stop sharing somehow. There we go. Oh, I've lost it. Oh, boy.
You can stop sharing this, James, and then share again.
I can't see how to stop sharing.
Oh, okay. Okay.
Hang on. Oh, stop share. Got it.
Okay.
Oh, yeah. Okay. So I'm going to go through the, it's a speeded up version of doing a construction of an Islamic tiling pattern. No calculations are involved. Only one size circle is involved, and it's all done by symmetry. That's the Shunyam Sutra, and Willow Kanam by observation, and transpose and apply a repetition. And you'll see it's about 3 minutes long. Hmm. I'm just going to go back to the PowerPoint. Okay, just to summarize, the Euclidean approach to mathematical relationships is very formal and very exact. The certainty of each proposition is established through previous certainties combined with deductive logic. Through the Pramanas, the traditional approach to geometrical certainty in India is more fluid and places a greater emphasis on human experience. Intricate patterns of Islamic geometry appear to use observable symmetries without the need for calculation. And finally, all approaches are entirely valid and so serve particular needs. The Vedic Math Sutras apply to all of these approaches and so have an overarching and universal presence. Thank you.